Hi everyone, welcome back. As you all know me, this is Pavitra pursuing third semester in the Department of Computer Science and Engineering at Sri Venkateswara College of Engineering, Bangalore. And in today's video, I'll be discussing about the subject operating systems. Here are the table of contents. Firstly, we'll see some introduction about memory allocation and then what is worst fit, advantages and disadvantages of worst fit, program structure overview, defining memory blocks, allocation function, deallocation function, user interface, and conclusion. Introduction to memory allocation. Memory allocation is a crucial aspect of operating systems that manage how memory is assigned to various processes. Different techniques exist for allocating memory, each with its own advantages and disadvantages. Contiguous memory allocation is a method of allocating memory in a single contiguous block. It is essential for efficient memory management in operating systems. This presentation will focus on the worst fit technique of a memory allocation. What is worst fit? It is a memory allocation strategy that allocates the largest available block of memory to the process. The idea is to leave the largest possible leftover space for future allocations. This technique is often used when processes have varying size requirements. Now let's see some advantages. One of the main advantages of burst fit is that it can help to minimize fragmentation over time. Burst fit can reduce fragmentation by leaving large blocks available for future requests. By leaving large block of memory available, it allows larger process to be accommodated later. It can be particularly effective in systems with processes of varying sizes. It may improve the likelihood of successful allocations for larger processes. This method can be beneficial in scenarios where large memory requests are common. Disadvantages of burst fit. A significant downside to burst fit is that it can lead to inefficient use of memory, as smaller processes may be left with insufficient space. It may also cause increased fragmentation, as larger blocks can become unusable due to scattered smaller allocations. In certain scenarios, it may perform worse than other strategies such as best fit or first fit. The main drawback of burst fit is that it can lead to inefficient usage of memory. This strategy can result in smaller free blocks becoming fragmented over time. It may not always provide the best performance compared to other allocation strategies. Program structure overview. The C program will consist of functions that allocate and deallocate memory blocks using the worst fit technique. Key components of the program include an array to represent memory blocks and functions for allocation and deallocation. The program will also include a user interface to input process sizes and display memory status. Pseudocode overview. To implement worst fit in C, we start with a memory block list and process request. The algorithm iterates through memory blocks to find the largest block that can accommodate the request. If found, the block is allocated and the remaining space is updated accordingly. Memory structure in C. We define a structure to represent memory blocks, including size and status. An array can be used to store multiple memory blocks representing the available memory. These structures will help manage memory allocation and deallocation efficiently. Defining memory blocks. Memory blocks will be represented as an array of integers indicating the size of each block. The program will initialize these blocks to simulate available memory. This representation allows for easy tracking of which blocks are allocated and which are free. Allocation function. The allocation function will search through the memory blocks to find the largest available block that fits the requested size. If a suitable if a suitable block is found, it will be marked as allocated and the remaining space will be updated. The function will return the index of the allocated block or indicate failure if no suitable blocks is available. Implementation steps. Initialize the memory block with predefined sizes and statuses. Create a function to request memory usage using the worst fit strategy. Implement logic to update the memory blocks after allocation, ensuring correct tracking of free space. Testing and validation. Testing involves simulating various memory requests to evaluate allocation performance. Edge cases, such as requesting more memory than available, should be handled gracefully. Validation includes checking for fragmentation and ensuring all requests are processed accurately. Deallocation function. The deallocation function will allow users to free previously allocated memory blocks. It will update the status of the block to indicate that it is now free. This function will also ensure that the free blocks are merged if they are contiguous. User interface. The program will provide a sample text-based user interface for users to enter process sizes and view memory status. Users will be able to choose options for allocation and deallocation of memory blocks. The interface will also display current memory usage and available blocks. Sample code snippet. The following C code demonstrate the worst fit allocation process. It includes functions for displaying memory status and requesting memory. Error handling is integrated to manage cases where memory request cannot be fulfilled. Here you can see the code snippet. Now let's see the explanation about code. Arrays, block sizes, and process sizes hold the sizes of memory blocks and processes respectively. Void worst fit. This function implements the worst fit allocation strategy. Allocation keeps track of which memory block each process is assigned to. All values in allocation are initialized to -1, indicating that no processes are allocated initially. Worst index holds the index of the largest block that can fit the current process. If a suitable block is found, worst index is not equal to the process is allocated to the block. The size of block is reduced to reflect the memory consumed by the process. Here the program first asks the user to enter the number of memory blocks, M. It then reads the size of the M blocks and stores them in the block sizes array using a for loop. Similar to the blocks, the program asks the user to enter the number of processes and their sizes. It reads the size of the n processes and stores them in the processes size array. The worst fit function is called with the block sizes, the number of blocks, the processes size, and the number of processes are as arguments. This function performs the actual memory allocation using the worst fit. Conclusion. The worst fit memory allocation technique offers a unique approach to managing memory in systems with variable process sizes. While it has its advantages and disadvantages, it is essential to understand how it operates within a larger system. The C function developed with simulate worst fit allocation and provides insights into its effectiveness in memory management. Thank you for watching. Please do like the video.